13.2. Figure shows the interaction of the cation, that's the positive ion right here, with surrounding water molecules. The water molecules are oxygen and 2 hydrogens. Oxygen, 2 hydrogens, oxygen, 2 hydrogens. The oxygen's red and the hydrogens are white. Which atom of water is associated with the cation? Well, that would be the oxygen, because the oxygen would be negative because there's a dipole moment inside of water that has a positive charge then on the hydrogens and a negative charge over here on the oxygens, and that negative charge is associated with the positively charged cation. I made up the cation to be sodium. It doesn't necessarily have to be sodium, it just is something positive, and so the negative part of the water molecule attracts to it and solvates it. Letter B, which of the following explanations account for the fact that the ion-solvent interaction is greater for lithium, so this being lithium, rather than potassium? So why would water more attract to lithium than to potassium? Well, the answer is that lithium has a smaller ionic radius than K+. As you know, radii increase as you go down a group or a family. And here's lithium and here's potassium. So potassium is larger. And lithium only has 3 electrons to start with. And so if you take one of those electrons away, there's only 2 electrons left to shield that nucleus. That nucleus is like very exposed and would have 3 protons in it and be very positive. The potassium ion, of course, would have 18 electrons, lost one of them, 19 to start with, so it would have more electrons around it, making it larger to get to that nucleus. And that's why lithium would be greater ion-solute interaction, because it's smaller and more like a point charge that could be attached to the negative part of the oxygens.